Hi, I hope you had a great day during your ISP integration fun day and also the trip to the zoo. I just wanted to try a different experiment where the lesson will be in this video, and by the time you come Thursday to class, we're gonna try and see how much of the video did you understand and how much of the concept can you really apply to some new problem solving. Well, we saw in this unit, especially in the textbook, a lot of this GCF acronym. And some of you have asked me, what does GCF mean, Stoika? Well, it means greatest common factor. And it's an acronym for greatest common factor. Now, I want you to think about, what does factoring actually mean? What is a factor? Well, we said that we factor a number, or we find the factors of a number, if we find the numbers that are multiplied to give a product. For example, for the numbers 12, 16, and 20, what are their individual factors? Well, for 12 we have 2, we have 3, 4, 6. What about 1? 1 could be a factor. 12. For 16, we have again 1, 2, 4, 8, and 16. And for 20, the factors would be 1, 2, 4, 5, 10, and 20. Well, if I look at all these factors, what is the greatest factor that is common to all three numbers? So if we look at and scan all the factors that we wrote down, we notice that the greatest common factor is actually 4. So 4 is common to 12, it is common to 16, and is common to 20. So the greatest common factor is number 4. Now let's look at a greatest common factor between variables. So whenever we look at variables, we have to see what do the three possible terms have in common. Well, here I have x. So possible factors would be 1 and x. Now for x squared, I have 1 and I have x squared. But I'm asking you to think, how can you make x squared by multiplying two separate monomials? Well, I'm hoping you remember exponent rules, and it's by multiplying x times x. So x would be a factor. What about for 2x squared? Well, I would have 1 and 2 and x squared. What would make 2x squared, the product of two numbers? And those numbers could be x and 2x. Now let's look at the three possible terms and determine what is the greatest common factor. Well, when I look at them carefully, x has the least number of factors, so it will drive my selection. Well, I have to choose between 1 and x. Or 1 will be a common factor for any number in this world or any variable. So I don't really want to take a look at it right now. The other one possibility is x. So does x squared have x as a factor? Yes, it does. Does 2x squared have x as a factor? Yes, it does. So the greatest common factor is x. Now, what do you notice about the greatest common factor for a variable? When we were able to decompose each one of these terms, we actually had to choose the variable with the lowest exponent, and we'll kind of formalize that in a little while. Let's find the greatest common factor for 7x squared, 28x to the power of 4, and negative 14x. Whenever we find the greatest common factor for monomials or for combinations between numbers and variables, we want to look at two things. Find the greatest number factor. So what is the greatest number factor for all of them? I'm hoping you can see it is 7. And the variable with the lowest exponent, meaning even the lowest exponent variable will be able to have whatever I'm choosing as a factor as its factor. So the lowest variable is x to exponent 1. So the greatest common factor is 7x. What about this one? 12a to exponent 3b, negative 16a squared b squared, negative 24a squared b cubed. Now let's look at the greatest number factor. So I'm going to write here greatest number factor. Okay, what is the greatest number factor between 12, negative 16, and negative 24? Well, 12 and 24 are divisible by 3, but 16 is not. So what is another factor that goes into all of them? It is 4. Now let's look at the exponent, the variables with the lowest exponents. And you always have to look at each variable individually. For a, what is the lowest exponent for all the a's? Well, here I have exponent 3, exponent 2, exponent 2. Therefore, my lowest exponent is exponent 2. For b, I have exponent 1, exponent 2, exponent 3. For b is exponent 1, or just b. So 4a squared b, 4a squared b. Now, how do we use this greatest common factor in actual algebra? Where is it going to become very useful in problem solving? Well, to factor the greatest common factor out of multiple terms, we're actually going to have to work in reverse of the distributive property of multiplication. And I want you to remember, when we had the distributive property of multiplication, we had something like this. If I had 3x multiplied with 2x plus 3, right? We learned in distributive property that what's outside the bracket gets multiplied with every term inside the bracket. So 3x times 2x gives us 6x squared, and 3x times 3 gives us 9x. That was the distributive property of multiplication. Well, when we're factoring something out, I want you to do exactly the opposite. We're going in opposite direction. So I'm going to be given an expression, and I have to find the greatest common factor between the two terms and be able to regroup my expression as the product of two factors. Well, for the first one, what is the greatest common factor between 3x squared and 6x? Well, remember what we talked about. You're going to look at the largest number that divides into all coefficients. So what is the greatest common factor? 3. And you're going to take the lowest exponent on every variable. What is the lowest exponent? It is 3x. Now, when we're extracting 3x out of each term, I want you to imagine a very fine division line. We're not actually going to write it further than this lesson, but I want you to imagine that's the operation. I need to extract 3x out of 3x squared. But what does that extraction mean? It means division. So I'm actually going to divide each of my terms by that greatest common factor. And what am I left with? Well, 3x squared divided by 3x is just x, plus 6x divided by 3x is 2. Let's take a look at the second one. What is the GCF? Well, we have to take a look at the greatest number factor, which I'm hoping you see is 5, and the variable with the lowest exponent, in my case, p squared. And again, we talked about that imaginary division line. Imagine you're dividing every term in your expression by the greatest common factor. So what is 5p cubed divided by 5p squared? Just p, and then minus 3. Next one. What is the GCF? What is the greatest common factor? Again, let's look at the greatest number factor between 12 and 18. I'm hoping you can see it's 6. And what are the variables with the lowest exponent? Well, for a's, the lowest exponent is 2, and for b, the lowest exponent is 2 as well. So what are we left with? Well, 12 divided by 6 is 2, a squared divided by a squared is 1, b squared divided by b squared is 1. So I'm just left 2 times 1, it's just 2, minus 3a, because b squared divided by b squared gives us 1 again. Okay, what about 4d? Do we have a greatest common factor? Well, it looks like all my terms have the same variable, w. So let's take a look and see what we're gonna get by factoring. We said we're gonna look at the greatest number factor. Now, are there any common number factors between 3, 7, and 4? I don't believe so. So I'm gonna take a look at the variable with the lowest exponent, which is w, and I'm gonna factor it out, being left with what? 3w minus 7w squared plus 4. Now please remember what we talked about in class. You're going to rearrange polynomials in descending order of the variable, so, or decreasing order of the variable. So it's w times negative 7w squared plus 3w plus 4. Well, what I would like you to do is to try on your own these next few examples at home. Just try them on your own, and hopefully by the time you come to class you will have the basic understanding of greatest common factor, and we can take a look at some more complicated examples on pages 3 and 4. I am gonna post this exact handout on my website under Unit 3 Algebra. Please feel free to download it and maybe tackle these challenges on your own. I'm not saying pages 3 and 4 are not challenging. They are quite a bit, since you haven't seen this kind of greatest common factor concept before, but I know you're up for a challenge, and it would be nice to see how much can you extend into some more complex concepts. Other than that, I'll see you Thursday in class. I will see you Thursday in class, and good luck finding the greatest common factors.